When I was 7, I asked my dad, "Where does space end?" He looked up at the night sky and said something that stuck with me forever. "Nobody really knows, son. It might not end at all." That answer planted a seed of curiosity that led me to study astronomy. Decades later, with powerful telescopes and advanced degrees, I can give you a better answer. We still don't know. But what we've discovered along the way is far stranger and more beautiful than I could have ever imagined as a kid. The question, how big is the universe, seems simple, but it pushes our understanding of reality to its very limits. The universe you can see, what we call the observable universe, is about 93 billion light-years across. That number alone is almost impossible to grasp. But here's the twist. That's just the part we can see. The actual universe. It could be infinite, and it's getting bigger every single second. When you ask how big the universe is, what you're really asking is, can my brain even handle this? And the honest answer is no. Our minds evolved to understand distances we can walk, not cosmic scales that take light billions of years to cross. To even begin, we need a new ruler, the light year. That's the distance light travels in 1 year, about 6 trillion miles. If you could travel at the speed of light, you'd reach the moon in a second and the sun in 8 minutes. But even at that impossible speed, crossing our observable universe would take you 93 billion years. Let's put this into perspective. The fastest spacecraft we've ever built, the Parker Solar Probe, would still take nearly 7,000 years just to reach the nearest star outside our solar system, Proxima Centauri, and that star is our next-door neighbor, just over 4 light-years away. That's how empty space truly is. So, let's take a journey. Starting from home, Earth is about 40,000 kilometers around. A plane can circle it in under 2 days. Now let's go to the sun, 150 million kilometers away. Light makes that trip in 8 minutes. We're still just in our cosmic backyard. Our solar system itself, out to its farthest icy reaches, is about 2 light-years wide. From there, the nearest star, Proxima Centauri, is another 4.24 light-years away. Imagine the sun is a grapefruit in New York City. The nearest star would be another grapefruit, ... in San Francisco. That's the kind of emptiness we're talking about between stars. Now, let's zoom out to our galaxy, the Milky Way. It's a swirling spiral disk of 200 to 400 billion stars, and it's 100,000 light-years across. Light takes 100,000 years to travel from one side to the other. Our galaxy is just one of about 50 in a gathering we call the Local Group, which spans 10 million light-years. The biggest galaxy in our group is Andromeda, 2.5 million light-years away, and it's headed right for us. In about 4.5 billion years, our two galaxies will collide and merge into one giant galaxy. But the Local Group is just a tiny suburb of an even bigger structure, the Laniakea supercluster, which contains 100,000 galaxies like ours. And Laniakea is just one of countless superclusters that form a vast, web-like pattern across the cosmos. This cosmic web is the largest structure in the universe. Finally, we reach the edge of what we can see, the observable universe. A sphere, 93 billion light-years in diameter, filled with an estimated 2 trillion galaxies, 2 trillion, each with hundreds of billions of stars. If every star was a grain of sand, there are more stars in our observable universe than all the grains of sand on every beach on Earth combined. So what's beyond that edge? Beyond the 93 billion light-year horizon? It's not a wall or an ending. It's simply the point where light from more distant objects has had enough time in the universe's 13.8 billion year history to reach us yet. The universe almost certainly continues beyond what we can see. Based on our best measurements, space appears to be flat, which means it likely extends infinitely in all directions. Some theories even propose a multiverse, where our entire universe is just one bubble in an endless, inflating cosmic foam of other universes. But there's another, stranger layer to this story. In 1929, Edwin Hubble discovered that space itself is expanding. Every distant galaxy is moving away from us. But the real shock came in 1998, when astronomers found this expansion is speeding up. Something is pushing the universe apart, against the pull of gravity. We call this mysterious force dark energy. And here's where reality gets truly weird. Everything you see, every star, planet, and galaxy, all the normal matter in the universe makes up only 5% of its total mass and energy, just 5%. About 27% is something we call dark matter. It's an invisible substance that doesn't interact with light, but its gravity holds galaxies together and shapes the cosmic web. We know it's there because we see its gravitational effects, but we don't know what it is. The other 68%, that's dark energy, the force driving the accelerating expansion of the universe. Think about that. More than 2/3 of everything that exists is a complete mystery. We are living in a cosmos dominated by invisible forces we are only just beginning to detect. So, in this incomprehensibly vast and strange universe, where does life fit in? We've already confirmed over 5,000 planets orbiting other stars, and we believe most stars have planets. If even a tiny fraction of the hundreds of billions of stars in our galaxy have a planet in the habitable zone where liquid water can exist, that's still billions of potentially habitable worlds in the Milky Way alone. With 2 trillion galaxies, the number of potential homes for life is staggering. This leads to one of the most haunting questions in science, the Fermi Paradox. If the universe is so old and so vast, filled with trillions upon trillions of worlds, where is everybody? The silence from the stars is deafening. We see no signals, no giant alien engineering projects, nothing. This implies there might be a great filter, some massive hurdle that stops life from evolving into a galaxy-spanning civilization. Is that filter behind us, meaning life itself is incredibly rare? Or is it ahead of us, a warning that advanced civilizations tend to destroy themselves? We don't know. But understanding the scale of the universe isn't just an academic puzzle. It changes your perspective. The universe is 13.8 billion years old, 93 billion light-years across, and filled with 2 trillion galaxies. And almost all of it is unconscious. Stars don't know they are stars. Nebulae don't marvel at their own beauty, but you do. You are the universe's way of knowing itself. You are literally made of stardust that has woken up and gained the ability to wonder about the stars. In all this vastness, your existence is a cosmic miracle. You get maybe 80 years, if you're lucky, to be a conscious witness to this incredible cosmic moment. So next time you look up at the stars, remember what you are. You're not just living in the universe. You are a part of it. A rare, precious, and temporary part that gets to experience the wonder of it all. Thank you for watching.